So welcome everyone for the EU edition of ROS-I developer meeting. So today we have Denis Stogl, who is basically the founder and CEO of Stogl Robotics, and also one of the main maintainers of ROS2 control. And for the last few months, he has been working on the ROS2 version of Kuka driver. So yeah, today he'll be presenting the work he has been doing so far. And yeah, hopefully we'll have a nice conversation. If you have any questions or use cases or yeah, any technical questions to Denis. So hopefully we'll have a very interactive session today. All right, Denis, please take over.
Yeah, just a second. Find the right screen. Okay. So here. Share. Can you all see my screen?
Yeah.
Great. Yeah. So yeah, thanks for the invitation and thanks for introduction. Just I don't know if I should say a bit more or something. I just skipped this slide because I had it before in the presentation. Probably all of know me basically for 2.5 years already. I'm working as robotics consultant here currently with a team from Karlsruhe, Germany. And we are active worldwide in very different industries, let's say. We also have industry in the underground mining client. So that's very interesting use case of ROS. Yeah, so let's check the presentation today. I want to keep it short now on ROS2 control because probably all of you heard already so much about ROS2 control and this introduction, I can imagine. So that's why probably it doesn't make sense to go there in detail. So yeah, I just want to show one picture and explain the basic concepts to see the context where we are and why we are doing. Then short introduction. Oh, okay, I thought I updated this. No, I updated this on the other slide. Let's check this slide. So then I will talk to you about external interfaces to Kuka robots, goals of the integration, what's the idea, what's the current state of the work, few of next step, and then resources and persons behind to see. So basic concept of ROS2 control, probably most of you know it already, but the idea is to have separated hardware management layer, separated controller management layer, and then dynamically connect those two so one can switch controllers online in the real time, and one can abstract hardware, so reuse controllers on different hardware. And also what is important, we are offering then interfaces in ROS2 control for other external libraries like movie 2, navigation 2, and so on, or you can also even create your own application. And most of the interfaces for the controllers didn't change in years, and they will probably not change very soon, so you get very stable behavior. So now let's see, when we are talking about Kuka robots, there are basically at the moment two options how to control Kuka robots. That's for one, robot sensor, using robot sensor interface or ROS-I communication. This is a streaming interface and it's perfect for ROS2 control and joint trajectory controller. Basically, since robot drives to the points it gets from the controller. A bit drawback of this interface is that it's very sensitive, so one has to respect the robot dynamic limits, and one has to have very hard time constraints. So usually either very powerful machine with dedicated CPU, or even better real-time kernel with clamping of CPU and so on. Nevertheless, for test use cases, it also works on a classical ROS setup if you just want to test it first. Then there is another interface, newer one, Ethernet KRL interface, or EKI known interface. This is more like move linear, move circular interface. It's like you are sending primitive commands to the robot. And although this interface exists in ROS-I and is also used with ROS control, it's not so great approach with current controllers in ROS control and ROS2 control. So yeah, currently, if you want to use it, you will probably not be happy, at least regarding performance. On the other hand, the interface is stable, is running. It's less sensitive than ROS-I interface, but it's not so performant at the moment. Then what is the idea? I mean, Kuka robots are common in many industries, so we want to have support for them in ROS2 control, and we want to reuse standard controllers, typically joint trajectory controller or admittance controller and so on. And if you are also using a bit more complex hardware setup, then you can profit from the hardware management functionalities from ROS2 control. And on the end, you get out-of-the-box integration with Movie2 and Nav2. Then, of course, one immediate goal is easier to work for students and researchers. At the moment, what we are working already now and in the future is also going into industrial use of this driver with our clients and in our setup. Yeah, to make it stable and to enable flexibility in the industries that industry needs slowly. So what's the current state of the work? If you want to test this, I would propose you to use rolling overview branch. It's not the most beautiful branch, but it works. It's well tested. It works with ROS-I interface out of the box, all rolling and humble. You also have Move-It integration with two files, example bring up file and reusable bring up file, for example, for your projects. This is also part of this work is also done as for a client in our project, and that's why we're also looking how to do some stuff more reusable and easier to use. And of course, there are still some old files in the repository. As I said, it's not everything cleaned up. Regarding EKI interface, there is Foxy version. This version is quite well tested on hardware. Our client is using this already for a year or so. It's working great, but it's messy. Let's say like that, and we didn't port it yet to rolling and didn't manage to clean it yet. So what is the next immediate steps? I was working today all day on trying to finish the ROS-I driver and ROS2 control integration for merging and rolling. Unfortunately, there are still probably 1 hour of work needed of cleaning and so on. This cleaning of files is just taking so much time to get this merged. And I would like when the commit get merged, then when pull request gets merged, then it's clean, so we don't have to go back to it. Then it's also idea here to do Foxy backport, which should be quite easy. And furthermore, we will focus on the EKI driver, merging for Foxy and rolling and testing it on hardware. This is actually will happen this Saturday in a lab. So yeah. And then after we have everything that, we will branch out for Humble. So currently, if you are on Humble, you can use your rolling version. This one works also on Humble. And finally, we have to revisit and update some docs. What is important, I just realized that I missed this here. We also, together with our client, extended ROS-I setup for newer KSS versions, so version 8.6 and above. Because ROS-I setup on the robot was changed. So there are additional KRL files. There is pull request with that. Since CI was failing, I didn't merge it yet. Nevertheless, all the manual is tested. So if you also want to use it on the newer robots, you can now use it. Just check this pull request, follow the manual there, and you can use it. And finally, some more resources about that. You can check the README file of the Kuka. This is where we will update for now the documentation, ROS2 control docs. Probably all of know it, and I would then also like to thank all the people involved. That was people from the University of Applied Sciences in Karlsruhe. Gergely and Mirko, who helped us a lot, two researchers there. Then what is interesting, the Kuka driver was actually the very first driver running a ROS2 control. Back then in 2021, in January 2021, immediately after first version, Dmitry Ignakov did this. And also thank to him for this great work. I have also somewhere the video recording with my phone showing this, but until now we didn't manage to clean it, everything, and do it nicely, because immediately Dimitri back then just wanted to test this, test ROS2 control, and basically he had access to Kuka robots, so he just hacked things around to work. And also from our team, there were multiple people involved on different stuff. Not everybody were working all the time. Giridhar did most of the work regarding porting and adding new files, creating movie setup, and so on. Daniel, he was working on the tests for a short time, and Manuel is working a lot on hardening stuff and testing and preparing this for the industrial environments. And that's basically it from my side. So I'm now open for questions.
Yeah, thanks, Denis, for the presentation.
Yeah, you're
welcome. I also see some of the other developers also are part of the meeting here. I see Giridhar at least. So if anybody in the audience have any questions to Denis or any of the other developers. Denis, are you already looking for beta testers, or have you already started contacting developers or system integrators or anybody?
we have already beta testers. FZI is just using this since this week or something. I was also with the guys today having lunch, and they are successfully using it. They are using at the moment this what is called the rolling overview branch, and this one is working great. I mean, we are also working doing this in a project with a client, so we are constantly testing this also on a robot. Of course, different robots and so on would be great to have it really tested through, but this will take time.
And would you continue maintaining it after your current development?
Yes, that's
the support?
idea. That's the idea. I don't want to basically talk toward the future, but you will see at ROS Industrial Conference why we will maintain it also in the future. Let's put it like this, yeah.
All right. Yeah, Benoot has one question.
Yeah, thanks, Denis, for the presentation. I have just one question about the Kuka ROS-I. In addition to the joint streaming, has also the Cartesian interface. Is there any plan to use Cartesian interface directly from the robot side? Or
Do you mean? I mean, on the EKI, both are
no, on the
possible.
ROS-I. ROS-I
On
itself.
the
ROS-I itself
ROS-I,
has.
yes, I'm having a meeting with the client on Monday, so we will talk about next project phase. There are multiple ideas for their setup. We will probably also have to add access to IOs of the robot through ROS-I, which is possible, and also Cartesian interface and everything. The thing is, this is ROS-I setup. So if we will do that, basically we will share example files, how this can be used, and we can then also share controller, how this can be done. But if we not do that in the project, then we will not spend time on writing ROS-I configuration files. But if you need any help how to do that, and you would like to do that, I can definitely point you what you can do on the ROS2 control side. You would just need to fight through the KRL files on your own. Because I'm not a great expert in KRL files. I know as much, so I can run ROS drivers. I can configure them, but for me, it's also reading a lot of documentation always when I'm changing something there. So yeah.
Yeah, but I will contact you maybe in the future for the help. Thanks. Thank you very much.
Yeah, of course. So yeah, one also interesting or important thing what we did, or what we are also adding to the repository is additional specialized node. The similar as is done on UR driver, now in ROS2, because I mean, this is for ROS-I, because ROS-I is very sensitive on timings. So basically the robot, we are using blocking call, and the robot is giving then the speed of the update loop. So there is then a node which is or per default you can use only one robot, let's say like that, because otherwise only one robot with ROS-I, otherwise you will end up in timing collisions probably. I mean, there are different possibilities how to do that. We have some great new features in ROS2 control, which are basically supporting asynchronous interfaces, this would be possibility if you want to use multiple robots and synchronize them and so on. Except that what we also realize, depending on your hardware, that we have to use in one application of ours, is also we have to use steady clock. So if you have any problems, you can also check. There is a node with steady clock, which could help you to increase stability for communicating with the robot.
All right. Yeah. Any more questions? Giridhar, if you have any comments from your side? If Denis has missed something out. All right. Okay, I don't hear anything. So yeah, Denis, thanks a lot for the presentation. I'm sure a lot of people are eager to try it out, and hopefully you'll get a lot of feedback after this presentation about the driver.
Yeah, thank you for listening, and I hope you find it useful. And yeah, sorry that polishing out takes so much time. It's just incredible how much time I can put into it. Yeah.
And hopefully we'll see you at the conference in Bordeaux.
Yeah, for sure.
All right. Okay, thanks everyone for joining. See you during the next developer meeting.
Thank you, everyone. Bye.
Bye-bye.